Hi everyone, my name is Kahim Wong. In this video, I'm going to present my master thesis. The topic is large-scale testing for ambiguous verb representation. First of all, I'm going to talk about the background of the thesis. The meaning of verbs and the structure of sentence are two aspects that construct language. In the field of NLP, many studies focus on modeling verb meanings, which encode verb into factor representation, usually by deep learning methods. On the other hand, uh, the grammatical structure of sentence can be formalized by assigning grammatical roles or dependence of verbs in a sentence. In the DiscoCAT proposed unified framework for the two type of model. Verbs are composed following their grammatical roles, so that the outcome of the model reflect both the meaning of verbs as well as the grammar of the sentence. Verb ambiguity is another characteristic of language. For example, a verb bank can be used to describe a financial institution or a land by a river. The conventional practice-based model had the limitation that all the meanings of a factor are collapsed into single factor. In paper 2, proposed to use density matrix to model verb meanings. Density matrix is compatible with DiscoCAT framework so that we are able to compose density matrix according to their grammatical roles. In practice, paper 3 proposed a model to learn density matrix representations from a large corpus in an unsupervised manner using neural network. So here we discuss some of the limitation in the current models. The use of DiscoCAT framework is still remain in some static and simple compositional rules. Also, there's no implementation for pre-group model. So in this thesis, we propose model to deal with complex structure sentence within the DiscoCAT framework and using density matrix modeling verb meanings. First of all, we'll describe the dataset we use to evaluate the quality of embeddings in terms of word sense disambiguation. As shown in the table, each sample in the dataset consists of a pair of sentences in which share the same target verb. These two sentences provide different contexts, and the aim is to classify whether the target verb had the same meaning in the two sentences. Since there are no implementation of pre-group model, dependence parsing is an alternative way to define grammatical relations. spaCy is a Python library provide a fast and accurate dependency parser. This formal grammar use a direct arrow to indicate verb-to-verb relations, as shown in the figure. To obtain verb embeddings of target verb, a straightforward method is to compose target verb with the neighbors. However, this method simply neglects the grammar of the sentence. So we need a hierarchical data structure to deal with this problem, and also to deal with the non-associative and non-commutative composition function. We propose to use a tree structure to organize and store verbs within a sentence, so that the part of speech of the verb, the dependency, the density matrix representation of the verb can all be stored in a node. This tree structure is compatible with the DiscoCAT framework. Meaning of verb is stored in each corresponding node, and the connectivity of the tree express grammatical relations. inherit from the tree structure. Now verb in a tree can be composed by tree post-order traversal. So the composition progress algorithm is shown here, and the figure shows is an example of tree post-order traversal. In a tree structure of sentence, there are some operation can be accomplished to modify the tree. The first operation is to drop node. Is because not all the verb is useful for composition, such as determinant or punctuation mark. Would not provide any useful information for work sense disambiguation. And deal with the non-commutative operation function. To deal with non-commutative functions, we should determine the position of arguments by record a tag in each node. So the third operation is to switch node to determine the order of compositions. If a parent node had multiple child nodes, this operation is to deal with non-associative function. And the fourth operation is called max level, which determines the depth of a tree. So here we provide an overview of our model for the Disco CAP. For the word in context data set. Since the number of sense of a verb is strongly related to the von Neumann entropy of the corresponding density matrix. For example, in an extreme case where the entropy of a verb is 0, means there's only one sense in the verb. Regardless of the metric, the label should be same sense. To navigate this finding, we adjust the matrix according to the entropy, and the equation, the adjust equation is shown here. So here shows the result of our model compared with some of the recent models. So our model are better than non-bird-based models, while there are still a huge gap compared with bird-based model. Compared with neural-based model, our model has extremely less parameters, which means less computational time and space are required. Meanwhile, our model is more interpretable. Neural network-based model often serve as a black box model, where the internal mechanism is unknown, while our tree models are rule-based, navigating prior grammatical knowledge. Considering the inflection of hyperparameter, we only consider the tree verb model here due to the limit time. Overall, to reach a high accuracy, the setting of each parameter is crucial. Some interesting finding using noun as operator, but then other setting. Considering the use of different metrics, since quantum measure has some flaws, which make it not the best metrics compared with the other two. And the adjust metric is an effective way, since is an effective way to improve the accuracy. Note that the alpha equal to 0 means that does not perform any adjustment. When the max level set to be 1, is saying that only verb with, only verbs with direct relation with target verb is considered and is not sufficient for work sense disambiguous. And that is the end of my presentation. Thank you.